Hey everyone, and welcome back to Study with Pröf Düdü. Today, we're going to tackle a really cool math idea called sets, and a tool I bet you've seen before, Venn diagrams. And trust me, they're way more than just a couple of overlapping circles. They're actually a super powerful way to organize information and solve puzzles that seem, well, impossible at first. So let's get right into it.
But hang on, before we dive in, if you find this lesson helpful, could you do me a quick favor? Go ahead and hit that like button and subscribe to the channel. Oh, and don't forget to click that little bell so you get notified about new lessons. It really helps me out and lets me know you're enjoying the content.
All right, let's start with a little puzzle to get our brains warmed up. So, picture this. Last June, there were 15 windy days and 20 rainy days. On top of that, we know there were 5 days that were just perfect. Not windy, not rainy. Okay, so if you add those numbers up, 15 plus 20 plus 5, you get 40. But wait a second. June only has 30 days. So how on earth is that possible? Go ahead, give it a
It feels like a trick question, doesn't it? I promise you it's not. The answer is hidden in a math tool that's specifically designed to sort out exactly this kind of messy, overlapping information. And by the time we're done here, you're going to know exactly how to solve it.
So, here's our game plan. We've already started with our puzzle. Next, we'll figure out what a set even is. Then we'll learn the special language and symbols that go with them. After that, we'll learn to draw sets using Venn diagrams, see how to combine and separate them, and finally, we'll come right back around and crack that weather puzzle.
All right, section 1. What in the world is a set? Let's start with the most basic building block of this whole idea.
In math, a set is just a fancy word for a collection of objects. Seriously, that's all it is. And the individual things inside that collection, we call those its elements. You know, we actually use this idea all the time without even thinking about it. We talk about a flock of birds or a herd of cattle. Those are just everyday words for a set.
Okay, now there is one really important rule here. For something to be a proper set in math, it has to be well-defined. This just means we have to be able to say for sure what's in the set and what's out. For example, the letters in the English alphabet. That's a great set. We all agree there are 26 of them. But what about the set of tall people? That's not a set, because tall means different things to different people. It's ambiguous. There's no clear rule.
Okay, section 2, the language of sets. Now that we've got the basic idea down, let's learn the special way we write and talk about sets in math.
So, whenever we write out a set, we always use these curly brackets. You see them right there. So if we wanted to talk about the set of odd numbers that are less than 10, we'd write it out just like that. S equals, curly bracket, 1, 3, 5, 7, 9, close curly bracket.
And you know mathematicians, they love their shortcuts. So instead of writing is an element of over and over again, we use this little symbol here that kind of looks like a curvy E. So if our set A is 3, 4, 5, 6, we can just write 3 epsilon A. And if you put a line through it, it means the opposite, is not an element of. So for that same set, we'd write 8 not epsilon A. So much faster.
Now, sets really come in two main flavors, finite and infinite. A finite set is one where you could eventually count all of its elements. It has an end. But an infinite set, well, that just goes on forever. No matter how many you list, there's always one more. Think about the set of all even numbers. 2, 4, 6, 8, and it just keeps going.
So we know a set can have a few elements, or even an infinite number of them. But can a set have 0 elements? You bet. We call that the empty set, and we use this symbol for it. It is literally the set with nothing inside. For example, what if I asked for the set of even prime numbers that are bigger than 5? Well, the only even prime is 2, so there are none. That set is empty.
Okay, section 3, drawing sets. We've got the definitions down, we've got the language. Now for the really useful part. Let's visualize all these ideas using Venn diagrams. This is where it's all going to start to click.
Before we actually start drawing, we need one last bit of vocabulary, because it's so easy to see in a diagram. It's the idea of a subset. Basically, a set S is a subset of another set T if every single thing in S is also in T. And we use this little symbol for it. A really easy example is that the set of all owls is a subset of the set of all birds, right? Because every single owl is a bird.
And that brings us to the Venn diagram itself. It's such a simple but brilliant way to see how sets relate to each other. We always start with a big rectangle, which we call the universal set. Think of this box as containing everything we could possibly care about for this one problem. Then, inside that box, we draw circles to represent our different sets.
So, we can draw our sets, which is great, but the real power comes from what we can do with them. We can actually perform operations on sets, a lot like how we add or subtract numbers.
There are three main operations we're going to look at, all right here in this table. First, we have intersection, which uses this upside-down U symbol. The key word to remember for this one is AND. It's the stuff that belongs to both set A and set B. Then we have union, with a regular U. The key word here is OR. This is the stuff that belongs to set A or set B, or even both. And finally, we have the complement. That's just a fancy way of saying not. It's everything that's not in set A.
And here is what that actually looks like on a Venn diagram. You see that little area in the middle where the two circles overlap? That's the intersection, the elements that are in both sets. And if you were to color in both circles completely, that whole shaded area is the union.
Okay, team, we have all the tools we need. We know what sets are, we have the notation, we can visualize them with diagrams. It's time for the payoff. Let's go back and finally solve that weather puzzle.
Okay, just to refresh our memory, June has 30 days total. We were told there were 15 windy days, let's call that set W, and 20 rainy days, which we'll call set R, and we also know that 5 days were completely outside both of those sets. Our job is to make it all add up to 30.
So here is our step-by-step plan. First, we draw our Venn diagram, two overlapping circles for windy and rainy. Now, this is the most important tip I can give you for these kinds of problems. Always try to figure out the number in the overlapping part, the intersection first. If you can find that number, everything else just falls right into place.
Let's think this through. The whole month is 30 days. We know 5 of those days were nice and sunny, so they're outside of our circles. That means the total number of days that were either windy or rainy has to be 30 minus 5, which is 25. Okay, but hold on. If we just add the windy days and the rainy days, we get 15 plus 20, which is 35. So why is our number 10 too big? It's because the days that were both windy and rainy got counted twice. We counted them once with the windy days, and we counted them again with the rainy days. That extra 10 is the overlap.
And that is the solution to the puzzle. There were 10 days that were both windy and rainy. Now everything makes sense. If we put 10 in that middle section and the whole windy circle is 15, then the windy only part has to be 5. And if the whole rainy circle is 20, then the rainy only part has to be 10. And now let's check. 5 plus 10 is 25, plus the 5 nice days outside, and that gives us 30. It works perfectly.
So, the big takeaway from all this is that set theory isn't just some abstract thing you learn in math class. As we just saw, it's a really practical, logical way to organize information and solve real problems that might seem confusing or even impossible at first glance.
So I'm going to leave you with a final thought to chew on. Now that you have this tool in your toolbox, where else could you use it? Think about all the confusing situations in your life, maybe figuring out your friends' schedules, or which classes your friends share. What kind of mess could you clean up just by sorting it into sets?
And that's a wrap for today's lesson. Thanks so much for studying with me, Pröf Düdü. If this explainer helped you out, please give it a thumbs up, subscribe for more math lessons, and make sure you hit that notification bell so you'll be the first to know when the next one drops. I'll see you all next time.